All right. Diving in today, getting down to the nuts and bolts of Python.
Yeah, we're talking strings, those essential bits of text, conditional statements, those logical brains of your programs, and loops.
Loops, the engines of repetition, these are really, if you think about it, the core tools you need for, well, pretty much anything you want to do in Python.
It's true.
We've got a whole stack of resources here, breaking down exactly how you manipulate strings, how you get your code to make choices using these conditional statements, and the real power of automation that you get from using loops. So in this deep dive, what we really want to do is, I guess, pull out those practical, most useful parts of all this and just see what kind of amazing things you can really build with these tools.
It is amazing, actually. When you dig into these fundamental pieces, it's incredible what you can achieve with them. Python's given us all these built-in tools for working with text, for controlling the flow of your programs based on different situations.
Yeah, it's all about logic, right?
Right, making those smart decisions in your code, and for just taking tasks that would be so tedious to do by hand and making them happen automatically. So it all comes down to understanding these core building blocks.
That's it, the foundation. Okay, well let's start with strings. On the surface, they seem like, I guess, a pretty straightforward concept, just a bunch of characters strung together, literally.
Right.
But our sources show that there's a lot more to them than you might think. I mean, take indexing, for example. It's basically like assigning an address to every single character in a string, and we start counting from 0 in Python, which is always a little quirky when you're first starting out.
Yeah, it can throw you off.
So in the word Python, the letter P is sitting there at address 0, Y at 1, and so on. But here's what I find really useful. You can actually count backwards, too, using negative numbers.
Oh yeah, negative indexing.
So -1 gets you the last character in the string, which would be n in this case. It's like a shortcut to the end.
It is, and that's really important for being able to pick out those individual parts of a string that
Yep.
you might need. And then building on that, you've got slicing. With slicing, you can grab whole chunks of a string, those substrings.
Yeah, like if you had Python programming, it's our go-to phrase today, and you wanted just the Python part.
Exactly. You could use something like s.6, and that'll give you exactly Python.
Okay, so 0 up to 6, but not including the sixth character.
Right. That ending index, it's like a boundary. You go up to it, but don't include it.
Eh.
And the cool thing is you can leave the beginning or the end index blank, and Python's smart enough to figure out that you mean from the very start or all the way to the end of the string. Like, it fills in the gaps for you.
That's pretty handy. And then there's this whole idea of negative slicing, which I gotta admit, when I first saw it, it was like, wait, you can do that?
Yeah, it's pretty neat.
You're using those negative addresses to slice from the end of the string backwards. It's like working in reverse. So on our Python programming example, S11-1 would give you programming.
Yeah, you just got to remember the last character is at NaN just 1, and then you count back from there.
Right. And it's really handy when you want to work with the end of a string, but you don't necessarily know how long the whole string is. It's like a flexible way to grab those last few characters without having to count everything out. And then there's step slicing. This is where you can, grab every other character or every third character or even reverse the whole string. You
Yeah.
just add another colon and then a step value.
Yep.
So like S.1 8.2 would give you pitorgam, again, from our trusty Python programming. It's incredibly flexible for extracting patterns from your strings.
Yeah, these indexing and slicing tools, they're essential.
Mm-hmm.
If you're trying to pull specific pieces of information out of, I don't know, maybe a log file, or if you're, breaking down what a user types in,
User input, yeah.
this is how you do it.
Okay, now strings aren't just static chunks of text. You can actually do things to them, perform operations on them. I guess the most basic is concatenation, which is just a fancy word for sticking strings together.
Right, gluing them together.
And you use the plus sign for that. So hello plus r plus world would give you hello world, as you'd expect. But you can also repeat strings using the asterisk, the star symbol. So hello times 3 would give you hello, hello.
Simple but effective.
Yeah, it's surprisingly useful for, maybe creating some simple visual separators in text, or if you need to quickly generate a sequence that repeats a certain pattern. It's a good way to avoid writing the same code over and over again.
Absolutely.
Okay, but The real power of strings comes from their built-in methods. These are like, I guess, specialized functions that are specifically designed to work on strings. We've got a whole bunch of them just for changing the case of a string.
Yeah.
So dot upper takes everything and makes it uppercase. Dot lower takes everything and makes it lowercase. Dot title capitalizes the first letter of every word.
No.
Capitalizes just the very first letter of the whole string. And then you've got swap case, which I mean, this is just Python showing off a little bit. It flips the case of every single letter.
They do like to have fun with it.
Yeah. It's pretty impressive how easily you can, reformat text using these methods. You're working with data from different sources. Maybe you need to standardize how things look in a report.
Right.
These case-changing methods are incredibly useful for that.
Especially if you're dealing with user input,
Oh, yeah, for sure.
People are going to type things in all sorts of crazy ways.
Exactly, exactly. So then you've got these methods for checking what's actually inside a string. So ice alpha will tell you if it's all letters. Dot-astigit checks
Yeah.
if it's all numbers. And then dot-asalnum checks if it's a combination of letters and numbers. And then .e-space
Yeah.
tells you if it's just spaces or tabs or those kinds of white space characters.
White space, yeah, the invisible stuff.
And then you have dot starts with and dot ends with, which, I mean, they do exactly what you think they do. They check if a string starts or ends with a specific sequence of characters. These are really, really useful, I think, especially for validating user input, making sure that, I don't know, maybe a file name ends with .txt or something like that.
Absolutely.
Yeah.
Input validation, that's a big deal. You want to make sure you're getting the right kind of data before you go and do anything with it.
Right. You don't want your program to crash because someone typed in the wrong thing.
Exactly.
Okay, now what about finding and replacing specific parts of a string?
Right. So you've got .find, which you give it the text you're looking for. So like .find world and hello world, and it'll tell you where it starts, like what index position.
So in that case, it would be 6.
Exactly. And then you've got .replace, which, as you might guess, it swaps out one piece of text for another. So .replace world, Python, is giving you hello Python. But it's really important to remember that strings in Python, they're immutable.
Immutable.
Yeah, you can't change them directly.
So it's not actually modifying the original string.
Right. All these methods, they're creating a brand new string with the changes you've made.
I see. Okay.
And that might seem a little roundabout at first, but it actually makes Python run more efficiently,
More efficiently. Okay.
especially when you're dealing with lots and lots of text.
So it's a trade-off.
It is. It's a trade-off for performance and for making sure everything behaves predictably. When you pass a string around in your code, you know it's not going to change unexpectedly unless you specifically tell it to.
Got it. That makes sense. Now, what if you want to take a string and break it up into smaller chunks?
So that's where split comes in.
Right, okay.
Give it a separator, like maybe a comma, and it'll chop up the string at those points. So if you do split on apple, banana, grape, you get back a list, apple, banana, grape, each piece separated neatly.
Oh, that's handy. And I guess you could go the other way too, right? Combine a list of strings into a single one.
Exactly. That's where .join comes in handy.
Oh, yeah.
Yeah, so if you have a list like Python is fun, you could use .join to stick them all together with spaces in between.
Well, you got Python is fun.
Yeah, that's it. And this back and forth between strings and lists, it's super useful for working with, structured text data.
Okay, makes sense. Now, how about making our strings look exactly the way we want them to? Adding some style, making them presentable. That's where string formatting comes in.
Oh, yeah, string formatting. It's all about taking those raw bits of text and making them, well, pretty.
Python gives us a few ways to do this. One is the .format method, which lets you insert values into placeholders within a string, like my name is and I am .format, Alice, 25. It's like filling in the blanks.
Right. Those curly braces, they act as placeholders.
And then there's F strings.
F strings, much more modern.
Yeah, they came along in Python 3.6, and they're generally considered to be a more readable way to format strings. You just put an F before the opening quote, and then you can put your variable names right inside those curly braces.
Yeah, so it's like F, my name is name, and I am age years old. Much cleaner, much easier to understand what's going on.
Way more intuitive. And I guess our sources mention the % operator for formatting as well.
Yeah, but that's kind of the old school way of doing it.
Yeah, you might still see it in older Python code, but F strings are definitely the way to go now.
Absolutely. They're the standard these days.
Okay, now we should probably talk about escaped characters as well.
Oh, yeah, escape characters. Those can be a bit tricky.
They're special sequences that let you include characters in your strings that, well, you wouldn't normally be able to type directly, like, a new line character N to start a new line, or a tab T for indentation. And if you want to put a single quote or a double quote N inside a string that's already enclosed in those quotes, you can use NaNA.
It's like you're escaping from the normal meaning of those characters.
Exactly. And even the backslash itself, you need to escape it if you want to include a literal backslash in your string.
It's a bit meta, isn't it?
It is. And then there are raw strings, they're really useful for certain situations, especially when you're working with things like file paths or regular expressions. If you put an R before the opening quote, like RC users name documents, Python basically says, okay, I'm going to treat all these backslashes as literal characters. I'm not going to interpret them as the start of an escape sequence.
Right. So it saves you from having to double up those backslashes all the time, which can get messy,
Messy and error prone. Yeah.
especially with file paths, which often have lots of backslashes.
Exactly. Now, we mentioned earlier that strings are immutable. You can't change them directly.
Right. Can't just go in and edit individual characters in place.
So if you try to do something like, C0J on the string Python, you'll get an error. Python's going to be like, nope, not allowed.
Yeah, it's strict about that.
The only way to get a modified string is to create a brand new one.
So you'd have to do something like sjthon to replace that first character.
Okay, makes sense.
And it's important to really wrap your head around that concept of immutability because it affects how you approach working with strings.
Yeah, you have to think about it a little differently.
It can be a little counterintuitive at first, but it really helps with efficiency and predictability in the long run.
Okay, now you can actually go through each character in a string using a for loop, which we'll talk about in more detail later. But it's as simple as, for char in Python, print char. This lets you do all sorts of interesting things like analyzing the frequency of different characters or doing some basic text transformations.
Yeah, loops and strings, they go hand in hand. It's all about being able to process text in a systematic way.
Okay. And of course, we often need to convert between strings and other types of data. Python gives us some simple functions for that.
Right, so you've got star, which takes a number and turns it into its string representation.
So like start 100 would give you 100.
Exactly. And then you've got int, which takes a string of digits and turns it into an integer.
So 200 becomes just the number 200.
Right. And then float,
Mm.
which takes a string representing a number, maybe with a decimal point, and turns it into a floating point number.
Okay, so 3.14 becomes 3.14.
Exactly. These type conversions, they're super useful when you're working with data that might come in different formats.
Right, you might read something from a file as a string, but then you need to do some calculations with it, so you convert it to a number.
It happens all the time.
Now, how about finding out how many characters are in a string?
Easy peasy. You use the len function. So len hello world is going to give you 11 because there are 11 characters in that string.
Okay, straightforward enough. And when you compare strings, using operators like equals, equals, less than greater than Python's actually comparing them based on their underlying Unicode values.
Right, those numerical representations of the characters.
So apple is not equal to apple because lowercase and uppercase letters have different Unicode values.
Case sensitivity matters.
And ABC is considered less than BCD, and hello is greater than hello, all because of their Unicode values. It's like alphabetical order, but it's based on these numerical representations.
Exactly. It's called lexicographical ordering.
Lexicographical ordering. Got it.
Important for sorting lists of strings or when you're searching for something specific.
Okay, and last but not least, we should at least touch on Unicode and encoding.
Oh yeah, Unicode, a big topic.
A huge topic. But Python's got great support for it, which means you can work with text from pretty much any language in the world.
Yeah, you can have strings with, I don't know, Japanese characters or Arabic or Hindi, whatever you need.
Exactly. And when you need to, I guess, store or transmit text data, you often have to encode it into a sequence of bytes, typically using something called UTF-8, and then you decode it back into a string when you need to read it.
It's like translating it into a format that computers can understand.
Right. And one little trick with strings, you can actually use triple quotes, 3 single or double quotes, to write multi-line comments in your code.
Though it's not technically a comment, it's just a multi-line string that Python ignores.
Right. It's a bit of a hack, but it works. Okay, I think we've covered strings pretty thoroughly.
Yeah, we've gone through pretty much everything.
Let's move on to conditional statements. These are the things that give your programs the ability to, well, make decisions, to execute different blocks of code depending on whether certain conditions are true or false.
Yeah, this is where the logic comes in.
It's all about making your code smart, making it able to respond to different situations. And our sources highlight a few main types of conditional statements. The basic if statement, if else for handling two possibilities, if elif else for multiple conditions, and then the idea of nesting if statements.
Right, creating more complex decision trees.
Exactly. So the most basic is the if statement. It's basically saying, if this condition is true, then do this. And the syntax is pretty straightforward, if condition dot statement s. So if that condition evaluates to true, then the block of code that's indented underneath it gets executed.
And that indentation is super important in Python. It's not just for readability, it's how Python actually figures out which code belongs to the if statement.
Yeah, if your indentation's off, your program's not going to work right.
Exactly.
So a simple example would be like x use 10. If by 5, x is greater than 5.
Classic example.
Yeah, and in that case, it would print the message because 10 is indeed greater than 5. But if x was, say, 3, then nothing would happen.
The if block would be skipped.
Now, what if you want to do something else if that condition's not true?
Well, that's where if else comes in.
If else, okay.
Yeah, it lets you provide an alternative path for your code to take if that first condition isn't met. It's like, if this is true, do this, otherwise do that.
So you add an else dot block with its own set of indented statements.
Right, and a common example is like checking if someone's old enough to vote.
Oh, yeah. If their age is greater than or equal to 18, they can vote. Otherwise, they can't.
Exactly. That if-else structure makes sure that one of those two things always happens, depending on the age.
Okay, now what if you have more than two possibilities?
Well, that's where if-elif-else comes in.
If elif else, more branches in the decision tree.
Exactly. So you start with an if, then you can have one or more elif blocks.
Elif being short for else if.
Right. And each elif checks a different condition, but only if the previous if or elif was false.
And then you can optionally have an else at the end to catch any case that didn't match any of the previous conditions.
A default option.
Yeah. And a good example of this is, I guess, assigning a letter grade based on a numerical score.
Classic grading scale example.
So you could have an if for an A, an elif for a B, another elif for a C, and so on.
And maybe an else for anything below passing.
Okay, that makes sense. Now you can even put if statements inside other if statements.
Nesting your ifs.
This lets you create more complex conditions, basically.
Like checking if a number is both positive and even.
Right. So you first check if it's greater than 0, and then only if it is, you check if it's divisible by 2.
Exactly. It's like adding layers of decision making.
And Python also has this really concise way of writing simple if-else statements on a single line. It's called a ternary operator.
Oh, yeah. The ternary operator. It's like a shorthand of else.
The syntax is a little bit weird. It's value if true, if condition else value if false. But it can be really handy for assigning a value based on a simple condition, like, setting a status to adult if the age is 18 or older, otherwise minor.
Right. It keeps things compact.
And then, of course, you often want to combine multiple conditions in your if statements, and that's where logical operators come in.
Yeah, that and or and not.
So you might need to check if someone's age is over 18 and they have a valid ID.
That's an and condition. Both parts have to be true.
Right. Or maybe they get a discount if they're a student or a senior citizen.
That's an or condition. Only one part has to be true.
And you can use not to check if something is not true.
Like if a value is not negative.
Exactly. These logical operators give you a lot of flexibility in building more complex conditions.
It's all about expressing the logic you need in your code.
And Python also has these things called membership operators, like in and not in, which let you check if a value is present in a sequence, like a list or a string.
So you can check if, apple is in list of fruits.
Right. And then there are identity operators, is and is not, which check if two variables are actually referencing the same object in memory.
And it's important to remember that is different from equals.
Equals just checks if the values are the same, whereas is checks if they're actually the same object.
It's a bit of a subtle difference, but it can be important in some situations.
Okay, and we'll see later how you can use conditional statements inside loops to control what happens in each iteration.
Yeah, combining conditionals and loops is a really powerful technique.
And our sources probably cover some common mistakes people make with conditional statements.
Oh, yeah, like forgetting about indentation.
That's a big one.
Or accidentally using a single equal sign for assignment when you meant to use a double equal sign for comparison.
Oh, yeah, that's a classic.
And then, using a bunch of separate if statements when you could have used an if, elif, else structure.
It's all about writing cleaner, more efficient code.
Absolutely.
Okay, let's finally get to loops. Loops are really the workhorses of programming.
Yeah, they let you repeat a block of code over and over again.
It's all about automation, saving you from having to write the same instructions multiple times. And Python gives us two main types of loops: for loops and while loops.
So for loops are usually used when you know how many times you want to repeat something or when you want to go through each item in a sequence.
Like a list of items or a string of characters.
Exactly. And while loops are used when you want to keep doing something, as long as a certain condition is true.
So you might not know how many times you need to loop in advance.
Right, it depends on that condition being met.
The for loop in Python is pretty versatile. It's designed to iterate over each item in a sequence.
So if you have a list of fruits, like apple, banana, grape, you can use a for loop to do something with each fruit in turn.
Right, and you can also use the range function to generate a sequence of numbers.
Yeah, like if you want to loop 10 times, you could use range 10.
And for each number in that sequence, the code inside the loop would get executed.
It's a very common pattern for doing things a specific number of times.
Now, the while loop keeps running as long as its condition is true.
So you need to make sure that something inside the loop eventually makes that condition false.
Otherwise, you get an infinite loop, which is, not good.
Not good at all.
Yeah.
Your program will just keep running forever.
A classic example is, I guess, a countdown timer.
Yeah, you start with a counter variable, and in each iteration of the loop, you decrease it by 1.
And the loop keeps going until the counter reaches 0.
Exactly, and then the loop stops.
Okay, and Python also gives us these things called loop control statements to give us more fine-grained control over how loops behave.
Yeah, so you've got break, continue, and pass.
Break immediately terminates the loop no matter what.
Like an emergency stop button.
Continue skips the rest of the current iteration and goes to the next one.
Like saying, skip this one, move on to the next.
And pass is basically a placeholder that does nothing.
It's just there for when you need a statement syntactically, but you haven't actually written the code for it yet.
Right, it's like saying, I'll come back and fill this in later.
Exactly.
And just like with if statements, you can also nest loops, putting one loop inside another.
This is really useful when you're working with multi-dimensional data.
Like a grid of rows and columns.
Yeah, you might have an outer loop for the rows and an inner loop for the columns.
And that lets you process each cell in the grid.
Exactly. Or you could use nested loops to generate patterns.
Like a triangle of asterisks.
Yeah, that's a classic nested loop example.
We already saw how you can use a for loop to go through each character in a string.
And you can also use for loops to iterate over dictionaries.
So if you loop directly over a dictionary, you get the keys.
But you can use the .items method to get both the key and the value in each iteration.
Which is usually what you want, right?
Right, you usually want to work with both the key and the value.
Okay, and one last thing about loops. You can actually have an else block with a loop.
Yeah, it's a little less common, but it can be useful.
It gets executed if the loop completes normally without being interrupted by a break statement.
So it's like a way to say, if the loop finished without any problems, do this.
Okay, well, I think we've covered a lot of ground here. We've gone through strings, conditional statements, and loops.
The fundamental building blocks of Python.
Exactly. And with these tools, you can really build pretty much anything you can imagine.
From simple scripts to complex web applications, it all comes down to these core concepts.
So, listeners, with this solid understanding, you're ready to take on more advanced Python topics and tackle those challenging programming problems.
You've got the foundation, now go build something amazing.
Exactly. So, thinking about all the things we've talked about today, the flexibility of string manipulation, the decision-making power of conditional statements, the automation potential of loops, what kind of tasks or challenges do you think you could now approach with Python?
The possibilities are endless.
It's really up to your imagination.